All right, so welcome back to Dr. Carr Society Mission. Now let's look at how we can solve this. I wanted to leave this one, but people are asking, they want to know how that is also solved. So let's take the opportunity to discuss that one too. All right, so we have length x, dx here. You realize that this is complex. Usually, when we are integrating, we don't usually find the natural log of x. So when it happens that we can assume this is a complex. Once it's a complex, what do you call it, term, we can let u represent that. So if we let u represent that, then we're going to have we're going to have then we're going to have integration of u dx. But of course, this is also different from that, so we can't do that integration unless we let this also go in. So this becomes a little complex for us now, so that can also be represented by u and by v, so that we end up with u dv as expression. Now this has a formula. We have a formula for solving this. When we have u dv, we have a formula for solving that. So the formula is given by u times v minus integration of v du, and this is the formula. You can use this formula. So when you have different, what you are integrating is different from with respect, the one you are integrating with respect to this expression, and it comes in, it is in the form of natural log. This is the expression that we can use. This is the formula that we can use to solve or integrate that equation. Right, so from here, what we do is, from this expression, we need to, u and v, we can easily get, because we have already said u is that, so that becomes ln x times v. V is what? X, so times x. Now minus, we are supposed to integrate v. How do we integrate v? We said v is equal to x, okay? So if we are integrating it, we integrate this part. Integrate x. So if we integrate x, what are you going to get? If you're going to x, if you integrate x, you are going to get what? X 1 plus 1 divided by 2. So that is going to give us what? How? Sorry, that should have. Sorry for the interaction. We should have. We are integrating v with respect to d, so it will be the same expression here. Let's keep it, because we can't just straight away integrate v when this is u. So we keep the same expression here, and then we'll come back to it. And so how do we deal with that? We have to get this one expressed in the form of v before we can do that integration. So let's see from what expression can we get that. Let's see that. Now we've already said ln x, or natural log of x, is equal to u. So du dx, we're going to have what? 1 over x. That is the expression here. Okay? Because we know when you integrate natural log of x, you get the inverse. So the question comes down, and then the differentiation comes on top, and that is what we have here. Right. So let me write it well, so that I think this means, so that people will understand what I mean. So this is, we are saying u is equal to natural log of x. So du dx, which is the same ln x, this is going to give us the inverse, so this is going to give us 1 over x. That's what I mean. So from that expression, from here, then it implies that du dx is equal to 1 over x. We want an expression for u in terms of v. We want to express u in terms of v, so that we can do the integration of this part. We can't integrate v with respect to u because they are different variables. So to integrate, you must have the same expression, the same form here. So the v will be able to do that integration. If it is v du, another variable, we can't do that. So what will happen from here is that you can make du the subject. Du will be equal to 1 over x dx. But let's not forget, we said the v is equal to the x. Remember when we were starting initially, we said let this also be equal to v. The x here. Because this is complex, and this also because this is complex, we make it u. This becomes complex, so we also let it be represented by v. So we are saying that v is equal to x, or the same as the v is equal to the x, the same thing. So in that case, this expression will also be equal to, because the x is the same as v, it becomes 1 over u, 1 over v, 1 over v, 1 over v is equal to v. So that this expression here that we have here can be substituted into this equation. So this is what I mean. So from here, we can say that integrating u to v now becomes ln x minus integrating v. Now the u, we know the expression for the u. The u now is 1 over v dv, and this is going to give us x, then x minus, this is going to cancel that, and then we have integration of dv, which of course will come out as what? If we are integrating a constant, then we're going to get what? X. So x, then x minus what? V. And v, we have said v is equal to x, so we get x, then x minus x as the answer for what we integrated. Right, I think the blue color is not appearing very well, so I wanted to make a mixture of colors so that we can have some sort of a variation. Right, so